Okay, let's solve a problem similar to homework from section 5.1. So question number 1. Assume the random variable x is normally distributed with the mean mu is equal 84, standard deviation sigma is equal 5, and we need to find probability for x less than 79. Okay, we know that to find the probability we have to have z-score to be able to access to probability table, and that's the probability table here. Okay, standard normal probability, you can find it in files. All right, so how are we going to find it? First we need to find z-score, because we have to go from, because this is the first problem, let me explain a little bit and then we get going. So we have to convert x to z-score, not convert but calculate z-score from x, and then x will have access to normal distribution table. Okay, so since we have it's given x, y is the z-score is not given, so we have to calculate z-score. How are we gonna calculate our z-score? So z-score is equal, let me use red color, is equal x minus mu divided by sigma. All right, so z-score is equal, x is 79 minus mu is 84 and divided by sigma. One thing you need to keep in mind, your table, this z-score table, it's gonna show always the left tail, which means it's gonna show less than. It's always gonna be less than, right? Less than z-score, whatever the z-score is. Okay, there are tables that shows right tail, which is greater than, and there are tables that shows in the middle between let's say between this and this, let's say. Okay, you need to find between, but we're going to use only with table that is less than z-score. It's less cyan. Okay, but using this table we can find out also with no problem the for the ones that greater than x or greater than z-score accordingly, or between this x and that x, and accordingly between this z-score or that z-score. To get more information, please go over your lecture. Okay, back to our problems. So divided by, sigma is 5. So what do we get? 84 minus 79, it's gonna be negative 5, right? And divided by 5, it's gonna be negative 1. Now, to find our probability, so what we're gonna do, probability of x less than 79, since we have already less, so we don't need to change anything. It's the same thing, it's equal, we can replace with z-score, which is less than negative 1. Okay, so since z-score is less than, it's negative 1, I'm going to the table that has negative z-score. Here it is, we have negative z-score here. Yeah, here it is. And we have here, see, negative z-score. So, and we need to find negative 1. Z-score is negative 1. To find negative 1, let me see, I'm going to drag down here, negative 1, right here. Because we don't have any decimal, so this first column, it's going to be 0, 0, see? So, which means we have negative 1.00. This score identified with whole number and 2 decimals. I have a special video that explain how to work with this score. So please watch it and also the lecture. It will help you. So negative 1, which is gonna be 0.1587. So from here, I'm going to write down is equal 0.1587. Okay, so that's question 1. Let's go to question 2. So what do we have here? Again, x is normally distributed. Mu is equal 50. What do we have? Standard deviation is equal 7. It's similar, looks like. Oh no, this time we have x's, we need to find. See, now we have probability for x is greater than 40. Okay, greater than 40. So what does that mean? Our table will show less than 40. If this is my x greater than 40, which means I need this area, and my table will show this area less than. So we know that the entire area, the whole this bell shape, it's 100% of database, which is 100%, right? So whatever probability I find here, this equal question mark, whatever probability I find for this one, I will subtract that probability of that z-score and I will get the leftover, this one. Let's see. So first of all, we need to find z-score. Z-score is equal x minus mu, right, over sigma. X is 40, minus mu is 50, divided by 7. So how much it's going to be? It's going to be negative 10 over 7. So 10 over 7, it's going to give us 1.43. So it's it is approximately negative 1.4285, but since this score is usually represented by whole number and 2 decimals, so I'm going to round up till 2 decimals. Let me rewrite this. Negative 1.42857. So with clean conscience, I can put it approximately equal negative 1.43. So big numbers, 857. So this score is equal negative 1.43. Okay? So now we need to go and find probability for x is less than 40. We need to find less than first before we go for greater than, which will be equal probability for this score less than negative 1.43. And that is gonna give us, let's see, 1.43. Okay, negative 1.4. Here we have 1.4. Now we need 3. So I'm bringing down, it's going to be 0.764. 0.764. Let me write down. That is equal 0.0764. And this is for less than, which is this part. Okay, to get more than, which is subject of our interest, we are going to take the whole area, which is 100%, and minus what we have. So that's going to be probability for x greater than 40 is equal probability z-score, no, we'll do this, probability greater than 40 is equal 1 minus probability for x is less than 40, which is equal 1 minus 0.0764, and we are going to get 0.23, hold on, let me subtract 1 minus, I can do it here, 1 minus 0.0764, 1, 2, 3. So it's going to be 6, 9 minus 6, 3, 9 minus 7, 2. Here's going to be 9 and 0, 1, 2, well, I didn't add it, but I count it all. 6, 3, 2, 9. So it's going to be equal 0.9236. Now, here is the thing. Sometimes this the last decimal, let's say 3.6, doesn't match to the answer. In that case, if first time you place it there and it doesn't, let's say, approve, then you want to place this information in this calculator. So here we have, I have already prepared, raw score is 40, which is x. Then mean was 50 and standard deviation is 7. So once I calculate, I'm going to get z-score negative 1.4287. We got that. So probability less than 40 is 0.0765, which is, if you round till fourth decimal, it's going to be 0.0766. And we got 0.073 something, right? Slightly different. So this calculator is doing more precise, I would say. And here you have for greater than 40. Here it is, greater probability for greater 40, 1 minus. And this is it for the case if you need to find out between two x's. All right? Moving to next one. Question number 3. Here we have between two x's now. So when we have between two x's, right here, what do we need to do? First, we need to find, let's say this is my x 74, this is 78. So first of all, 74 and 78 x's, I have to convert into z-score. That's number one. Then I need to find probability for z-score less than this. And then I have to find probability for z-score that is less than from here. And then if I take this whole piece area and do minus this small piece, I will get the area in between. So let's do it. They say it's better 1 times to see than 10 times to hear, right? So z1, let's put z for x is equal 74. Okay. Oops. Let me see. Is equal 74 is equal. So what do we have? X is 74 minus mu is 86. Here we have the formula, remember? Here, x minus mu divided by sigma. And divided by sigma, which is 4. So let's see, 74 minus 86 is equal negative 12, yeah? Okay. and divided by 4, it's going to equal -3. Okay, now next, z-score for x is equal 78. It's going to be equal 78 because the mean and standard deviation is the same for both of them. 78 minus 86, okay, divided by 4. 78 minus 86 is -8, and -8 over 4, it's going to be equal -2. All right, once we have this both z-scores, now we need to find the probability for z-score less than -3, and then we need to find probability for z-score less than -2, okay? And then the probability for this one, for 78, z-score is equal -2, which here z-score is equal -3. The picture is not precise, both z-scores are negative, so I would say it would be, because z-score is negative, here is our 0, so below 0 it's going to be z-score negative, which is going to be, let's say, this is this and this. Okay, both of them will be negative. This will be this one, and this will be this one. Okay, all right. So less than 2, and whatever we have, we will do probability for z-score for 78 is -2, less than -2. I need to subtract probability for z-score is less than -3 because 78 is greater than 74. So I'll take probability of 78, which is -2, minus probability for less x, 74, and that will give me the probability between them. So let's go for it. -3 and -2. Here it is, -3. So since we have sharply -3, we are taking 0, right? This 0, which is going to be 0.0013. Okay? (0.0013). Okay, for for -2. Clean this. For negative, where is it? -2. First number 0.0228. Okay, 0.0228. So what do we need to do? We need to subtract 0.0228 minus 0.0013, and that is going to be equal. Let me subtract. So this is 5, this is 1, this is 2, 0, 0. And that is going to be equal 0.0215. Again, you check if first time it says wrong number, so that means the fourth decimal is going to be a little bit different. So let's check let's check what we get. So let me write down so I won't forget. Mu is 86, sigma is 4. Okay, and 74, 78. Okay. So mu is 86. And standard deviation is 4. Okay, here we have 74. By the way, I forgot to tell you, the link to this calculator is under the video, will be under the video. I have already placed under the lecture 5.2, and I will place under this video also. So this one we got 0. Let me start with 78. Hold on. I just punch because I'm going to punch on calculator difference. Actually, it will give us also. Okay, this is how much is less than 78? It's gonna be 0.02275. See, it's giving more precise. Okay, now we punch for 74. Okay, for 74 it's gonna give us 0.0013499, which means I'm going to subtract 0.0013499, and I'm getting 0.0, let me see, I'm getting 0.0214 instead of 0.0215. I'm getting 0.0214, and I could bet 0.0214 will work the same way with your homework answer also. Okay, so let's solve the next problem. For the next problem, we are going to use calculator already. So let's see what we have. In a recent study on world happiness, participants were asked to evaluate their current lives on scale from 0 to 10, where 0 represents the worst possible life and 10 represents the best possible life. The responses were normally distributed with the mean, okay, mu is 4.5, standard deviation 2.2. Okay, and now we need to answer. Evidently, x is going to be given. Oh, here it is. Find the probability that randomly selected study participant response was less than 4. So find the probability for x is less than 4. This is what it's going to happen. This mu and sigma, it's going to be common for every single question. And then it's going to suggest you different x's. Okay, so what do we have? We have mu 4.5, sigma 2.2, and we need to find less than 4. Let's go for it. So it's gonna be 4. Mean is gonna be 4.5. And standard deviation is going to be 2.2. So we need less than 4. So for less than 4, we're going to have a 0.3925. 0.3925. 0.03925. Okay, now between 4 and 6. All right, between 4 and 6, which means what we need to do first, we need to find probability. 4 we already have it, so we need to get probability less than 6, right? And then do probability x is less than 6 minus probability for x is less than 4. So, and what we are going to get, less than 6, 0.39. Okay, less than 6. It's gonna be 0.773. Okay, here there was no 0. Okay, so this one is going to be 0.73773. 3. Okay, so let's subtract 0.73773 minus 0.3925. I'm going to punch on calculator so it would be fast, otherwise I don't like to use it. And I'm getting 0.34523. Pay attention, it usually wants to round till 4 digits, which is going to be 0.3452. Let me clean this. Next, find the probability a randomly selected study participant response was more than 8. So when we have to find out more than 8, what we're gonna do? First we need to find probability x less than 8, and then do 1 minus probability x less than 8. And that will be probability for x greater than 8. So let's find less than 8 first. Okay. So we're going to have the same data, only x is going to be 8. Right? Go. So less than 8, it's going to be 0.93888. Okay? So probability for x, I can write down right here. 1 minus 0.93888. And that is going to give me 0.06112. Okay? Remember one thing. Every time when you will have to deal with greater than, you always need to subtract from 1. Okay? Next one. Actually, we can check on calculator. For greater than, it's giving you also. Let me see. For greater than, here it is, 0.061118, right? That's for x greater than 8. Okay. Moving to next one. Identify unusual events. Okay. The unusual events are going to be, let me see. Unusual the events, if we look, we are not going to have any unusual events because all the probabilities are greater than 0.05. Unusual events, we consider the ones that are less than 0.05. Okay, therefore, no unusual events. Okay, question number 5. So, in recent years, the score for the reading portion of a test were normally distributed with a mean of 20.9 and standard deviation 5.8. So mean, mu, is 20.9, standard deviation is 5.8. So we need to find A, probability for blah 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 blah, test score, x is less than 17. Less than 17, which is going to be equal probability for z score less than, how much it's going to be? Let me do the math. X is 17. 17 minus mu 20.9 is equal negative 3.9, and if I divide by 5.8, it's going to give me negative 0.67. And we will check now in a minute once we enter. Let me write down these numbers. 20.9 5.8 and 17. Okay, let's go. So x is 17. Mean is 20.9. And standard deviation is 5.8. Okay. So since we need to find less than, see, we got this score here, it shows negative 0 point, here it is 0.67241, so we did correct. And x is the less than probability for x less than 17 is gonna be 0.2507. 2507. Okay. 67 is equal 0.2507. So one more time, when you need to find less than, then you just find out probability and that's all. But when you have to find out more than, then you're going to subtract from 1. So now let's see from 17.5, the x is, we need to find probability for x greater than 17.5 and less than 24.3. Okay? Which means we need to find probability for x less than 17.5, and then we need to find probability for x less than 24.3, and then subtract from each other. Probability x less than 24.3 minus probability x less than 17.5. So, and obviously we have to go through z-score, right? So let me write down 17.5 and 24.3. Okay, let's go. So 17.5 and the rest is the same, right? Okay. It is gonna be, see, this score we have. Okay, probability x is less than, oh, did I write down? Hold on. $24.3 and 17. Yeah, 20.9 and yeah, we're good. By some reason I thought that mean and deviation are different. Okay, 17.5, calculating. Here it is, less than, it's gonna be 0.27887. Okay, and now we need also, how much is it? 24.3. 24.3. We go, and here we got 0.7213. 0.722113, and this one is 0.27887. So let me subtract 0.72113 minus 0.27887, and that is equal 0.4423 if I round it up. Okay, next, it's gonna be more than 32.7, probability for x greater than 32.7. So we need to find less than and subtract from 1. This is less than 32.7. Okay, so 32.7 No, I don't want this. I want this. 32.7. Go. Okay, less than it's going to be 0.970.905, which is going to be 0.02095. Or the second line, see, it's already giving you x is greater than. Okay, so let's plug in. This is going to be 0.02095. Okay, and last one, identify unusual event. What do we get? Look at that. We have in C, we have less than 0.05, right? In C, is probability is less than, it's a 0.021, it's which is less than 0.05, which means the event in part C is unusual because probability is less than 0.05. Question number 6. Okay, what do we have here? So the monthly utility bills in a city are normally distributed. Mean mu is 100. Standard deviation, sigma, is 13, right? And so it's practically going to be same way. We need to find probability of x is less than 65, right? So let me write down 113, and it's going to be 65. Okay, so we have 65, it's 100, and here we have 13. And for less than, we are getting 0.003548. Okay, it's going to be 0.003548. Now for between 82 and 90, so what do we need to do? We need to get probability for x less than 90 minus probability for x less than 82, right? Okay, so what we're gonna have, this is 90, which is gonna give me 0.22088. Okay, 0.22088 minus, now let's find out 82. It's gonna be minus 0.083085. Okay, 0.083085, and that is gonna be equal 0.137795. That's a probability. About 13.8% probability between 90 and 82. Okay? All right. Between 90 and 82, it's both of them are, one is it's positive. Okay. Now, more than 100. So to find probability x greater than 100, we have to do 1 minus probability x less than 100, right? So let's plug 100. And that's going to be equal 0.5. Why? Because it's right the same thing as a mean. Let's go back. Because my mean is 100 here, look. Okay, and it's x is 100 also, which means it's going to be right where average is, and average break down the database here by 50%, okay, which is going to be 0.5. Okay. Well, question number 7, it's exactly same way. So see question number 6. So mu is going to be equal 22, standard deviation 7, and the rest you can do it looking at problem number 6. 8. There we go. Here you need to find between. Here we have between. X is 471. So we need to find probability between x is greater than 200, less than 475. Okay. Mu is equal. Mu is 510. Here we have. And sigma is 125. Yes? So we are going to plug this data, 510 and 125, and then between 200 and 475. Let's go. So 200, x is 200. Mean is 510. And standard deviation is how much? 125. Let's go. 200 is 0.0066. Okay, 0.0066. Probability for x is less than 200. It's 0.0066. Now let's plug 475. 475, and it's going to be 0.3897. 0.3897. So probability between 200 and 475 is equal 0.3897 minus 0.0066. Okay, 0.3897 minus 0.0066. It's going to be 0.6037. Question number 9, it's exactly same way, so I'm going to put C number 8. Okay, here you have all information you need and solve the same way. And lastly, describe the shape of normal distribution. So what is the shape of normal distribution? For students who watch the video for the normal distribution, they know that normal distribution is roughly has bell-shaped, which is like this. I am not saying perfect, but if you approximate about it's going to be bell-shaped. Okay, that's all. Hopefully it will help you with homework, and I see you in next homework. Okie dokie. Bye-bye.